Hey everyone! Alright, today's video is going to be our introduction to probability, and we are going to start out by focusing on sample space. So your objective, I will be able to represent, using lists and tree diagrams, sample spaces for simple and compound events. So let's go ahead and talk about some of the vocab that you're going to see today. So an outcome, that is any one of the possible results of an action. So if you were to flip a coin, the outcome would be it's either going to land on heads or it's going to land on tails. A sample space is the set of all the possible outcomes for an experiment or situation. So in the case of flipping a coin, the sample space would show that it's either going to land on heads or on tails. A tree diagram uses branches to show the total number of outcomes. So a tree diagram is just showing your sample space, but it just shows it with branches instead. So here we actually have a tree diagram. Now what this is representing is getting an ice cream cone. So you have two different types of cones that you can choose from, a sugar cone or a waffle cone. And there are 4 different flavors of ice cream that you can choose. So what this is showing is if you get a sugar cone, you could also get chocolate ice cream or vanilla or strawberry or mint. But if you get a waffle cone, you have the same options. You could get chocolate, vanilla, strawberry, or mint. So this is just showing all the possible combinations with the 2 cones and the 4 types of ice cream. Alright, so let's go ahead and actually practice listing out sample space and representing them in tree diagrams. So on example 1, we are going to list the sample space for the following. So letter A says rolling a 6-sided die. So the options for that would be 1, 2, 3, 4, 5, and 6. So that's really it. We just list out all of the possible outcomes. Flipping a coin, it's either going to land on heads or it's going to land on tails. Simple as that. Now, if we were to flip a coin and roll a 6-sided die, well, it could land on heads, and then you could roll a 1. It could land on heads and you could roll a 2, and so on. So no matter what, we've got to make sure we represent every side of the die that it could roll on if you landed on heads first. Now let's say you landed on tails instead. So if you land on tails, you could then roll a 1, land on tails, roll a 2, and so on. Now if I were to make a tree diagram out of this, what I would do is start with the first action, so flipping a coin. So if we flip a coin, let me separate this out. It's either going to land on heads or it's going to land on tails. Now if it lands on heads, we could get 1 through 6, any one of those options or outcomes. So whether you list it out or make a tree diagram, it's showing you the same thing. So as you can see here, we have 12 total outcomes in the situation. Now you may have noticed that with flipping a coin, you have 2 outcomes. And with rolling a 6-sided die, you have 6 outcomes. And 2 times 6 is 12. So that is called the counting principle. So whenever we want to know the total amount of combinations that are possible in a situation, we can multiply the options together. So like in letter A, there was only 1 action. So I'm going to draw a line to represent that 1 action. And there are 6 outcomes. So that is the total number of outcomes in that situation. For letter B, flipping a coin, that is 1 action. And there are 2 outcomes for that. Now on letter C, we've got 2 different events happening. So we're flipping a coin, so that has 2 outcomes, and then rolling a 6-sided die, that has 6 outcomes, and then we just multiply them together to see that we have 12 total outcomes, and we can see that in the list and in the tree diagram. Alright, so example 2, at Sydney's Soda Fountain, you have many choices. Oh, sorry, I'm not talking well today. Cup sizes are large and jumbo. So there's the first option. Sodas are Coke, Dr. Pepper, and Sprite. So we want to construct a tree diagram of all of the possible combinations. But before we do that, I'm going to use the counting principle so that I know how many total combinations we should end up having. So again, remember the counting principle just means to multiply the options together. So the first thing that happens is in this situation is you have to choose your cup size. So you can either get large or jumbo. That is 2 choices. The next thing you have to do is choose your soda type, and that's either Coke, Dr. Pepper, or Sprite. You have 3 choices there, so if I multiply that together, we should have 6 total combinations. So we know that ahead of time. Okay, so let's start with the first choice, large or jumbo, and I'm just going to represent that with L and J. So if we get a large drink, it could be a Coke, it could be a Dr. Pepper, or it could be a Sprite. If you were to get a jumbo drink, it could be a Coke, it could be a Dr. Pepper, or it could be a Sprite. And that's it. And as you can see here, we have 1, 2, 3, 4, 5, 6 total outcomes for this situation. All right, now it is time for you to try. So make sure you read through the problem and answer it on Educanon. Since you can't actually draw out a tree diagram or make a list on Educanon, this problem is focusing on just the total number of combinations of meals you can make. But when we get in class, you will be constructing tree diagrams and drawing those out. All right, make sure you bring your notes to class with you and have a good day.